Okay, so lesson 19, part 2 is on properties of logarithms, and we're going to be doing something a little bit new where we're going to be expanding logarithms and condensing logarithms. Okay, so in order to do this, we're going to use two rules. So do you guys remember log of A plus log of B? Do you guys remember what that is? Log of A times B, right? And then what about log of A minus log of B? Yeah, log of A divided by B. And we learned that this happens because logarithms are actually exponents. They have the rules of exponents. So adding exponents is related to multiplication, right? And subtracting exponents is related to division. I guess there is one more rule that we'll use. We'll use the power property, which says if I have log of A divided, or A raised to the C, it's going to be C times log of A. We can pull powers to the front. Okay, so this concept isn't super important. It wasn't super important in like Algebra 2, even pre-calc, because we don't do a lot with it, but in AP Calc it allows us to find something called a derivative very easily. Okay, so we do this a lot in AP Calc, but we kind of preview it in pre-calc. Okay, so if I have log base 8 of 5y, I can expand this into separate logarithms. So if I expand it, it's going to look like log base 8 of 5 added to log base 8 of y. Make sense? Easy one. How about this next one? So we're going to have natural log of x squared minus natural log of what? You could do yz cubed altogether, but what about yz cubed? Aren't we going to break that apart even more? Okay, so what I could do here, well, maybe on the next line, I could do natural log of x squared minus, and then I could do a big parenthesis and break that apart. So I'm going to have the natural log of y plus the natural log of z cubed. Do you guys see how I did that? Because this was a product, like a times b. So it's natural log of a, natural log of b. So couldn't I just distribute that negative? Yeah, so it's going to look like natural log of x squared minus natural log of y minus natural log of z cubed. Do you guys think you could go straight from the first one straight to that without doing those intermediate steps? Yeah, so what's our rule? So anything that's on the bottom will have a minus in front of it. Does that make sense? Because it was divided. It was on the bottom, it was on the numerator. Anything that's on top will have a plus in front of it. Does that make sense? Okay, and one last step. So we're also going to pull powers to the front. So when I do that, I'm going to have 2 times natural log of x minus natural log of y minus 3 natural log of z. Does that make sense? So I just pulled these powers to the front. Yeah, and the reason that's nice is because in calculus we memorize a rule, like the derivative of natural log of x, the slope of natural log of x is 1 over x. So then we can say, oh, it's 2 times 1 over x minus 1 over y minus 3, 1 over z for the derivatives, but we don't do derivatives in pre-calc, no worries. All right, so the next one. So we're going to continue to break it apart. So we're going to have log of x squared plus log of the cube root of x minus 1. And then what? Minus log of 2x minus 1. Okay. And we're almost there, but we still have to take care of the powers. So our powers are going to be 2 times log of x plus, what's my power? 1/3, good, 1/3 log of x minus 1 minus log of 2x minus 1. Okay, and some people get a little expanding crazy. They decide they're just going to expand everything. All right, we're done here. So don't try to say that this last part is log of 2x minus a log of 1. Do we have a rule that says, like, the log of a minus b is, or a minus b is equal to the log of a minus log of b? No, we can't do that, right? So we can't expand this. Like, we can't distribute a log. That doesn't make sense. It's always log of something, and that something's going to stay the same unless it was multiplication or division. Okay, so that was expanding logarithms. Do we feel pretty good with that? Not so hard. How about condensing logarithms? So now we're going to go in the opposite direction. So the last thing that we always did is we pulled the powers to the front before. So that's going to be the first thing that we do now. So we're going to pull these powers. So like this power was 1/2. We're going to pull it up. So we're going to have log of 6 plus log of 9 to the 1/2 minus log of 3. So what is that? Log of 9 to the 1/2. Yeah, it's log of 3. Isn't that just this log of the square root of 9? Right? A 1/2 power is the square root. Yeah.
With logs, do you have to do plus or minus 3? Or
No.
is it just always positive 3?
It's always a positive because it's like the square root was already there. So log of 3 minus log of 3. Do you guys see how this all ends up being log of 6? Colt, you with me? All right, so the next one. So we're going to pull up the 3, we're going to pull up the 2. So we're going to have natural log of 6 plus natural log of x cubed plus natural log of x squared minus 2 squared. I always write my natural log in cursive. It bothers me that I didn't here. It looks like ones. All right, so I'm going to get natural log of 6x cubed x squared minus 2 squared. And that's the natural log of all of that, so I'm going to put a parenthesis around all of it. Does that make sense? Everything was kind of on the numerator. There was no denominator because I wasn't subtracting any of those out. Good? All right, kind of try the next one along with me, see if you really get it. Oops. Oops, got 1/2 there. All right, so what do you guys notice on this one? Anything? They're all log base 3, so we can combine them because they're all the same log. I have the same base. If it was like log base 3 and log base 5, I couldn't combine. What else? Greta?
Log of 3, 9 can be 2.
Yeah, this simplifies down to 2, right? So let's write it as 2 then. And then we'll combine the other ones. So I have log base 3 of y times x minus 2 squared. Okay, and I can leave it like that. Done. So the frustrating thing about AP Calculus for my students is that they use the log laws all the time, okay? And it's a multiple, like part of the test is multiple choice. And sometimes your answer, you're like, I know this answer's right. It wasn't a hard question, but their answers don't look anything like it. And sometimes it's weird simplification that they do, and it's not really making it simplified. So here's an example. So a few years ago, there was a question on the non-calculator portion, and many of my students wrote the answer as this, which I think is pretty simplified. It looks correct to me. Okay. However, the answer choices were like the following. Okay. Do you see how having an e there is kind of weird? Like when I have natural log of e, what is natural log of e? It cancels out. What is it? Does it just go away though? Let's think about it. Natural log is log base e. So if I'm saying e to what power equals e, what should it be? 1. So natural log of e is equal to 1. Okay. So some of these choices have like an e with the natural log, which I think is kind of weird. Okay, I wouldn't call that simplified at all. But those were the answer choices. So the question is, on the non-calculator test, how would you possibly know what those are equal to? It's kind of frustrating, right? If you had your calculator, you could at least put all those answer choices in and be like, okay, this decimal matches up with this decimal, found it. Okay, but it was on the non-calculator portion. Okay, so let's kind of talk about how we can get there. So the first thing I notice is that I have 3 natural log of 2. Well, we know how to at least change that. What's 3 natural log of 2 going to be? Natural log of what number? 8. Do you guys see it? Because we can pull the 3 up, so we get the natural log of 8. So I see that some of these choices do have an 8 in there. So it's like, okay, maybe it's one of these two, because there's a natural log of 8. But we also had -1 minus that. But these choices don't have like an additional term where there's like a negative 1/2 or a negative 1. So what we're going to do is we're going to write natural log of e, which is kind of weird, right? Negative natural log of e minus natural log of 8. When we do that, we can pull out a negative 1, and we have natural log of e plus the natural log of 8. What does that become? Yeah, it becomes natural log of 8e. So we at least have that. Now the rest of this was all divided by 2, right? Maybe I should put my 2 back in. So do we have one of those answer choices now? Yeah, it's the same as A. Tricky, isn't it? Really annoying that you have to think, oh, I'm going to change that negative 1, which is already pretty simplified, to negative natural log of e. It's really weird. Okay, so if you didn't know that, then go from this way, and you can start breaking down your answer choices. So you have negative 1/2, and then you have natural log of 8e. If you at least knew that you could break that up into natural log of 8 plus the natural log of e, you would be there, right? You'd have negative natural log of 8 minus natural log of e all over 2, and then you know that natural log of e is equal to 1. Okay, that would get you here. Does that make sense? So you can go backwards as well. You could take your answer choices and simplify them. All right. So that's something to keep in the back of your mind if you take AP Calc next year. All right, so change base formula. So this is a formula we learned last year. And we kind of don't use it very much anymore, but it says if I have log base b of m divided by log base b of n, I can change that to any base that I want. Okay? Well, actually, let's write it this way first. It's log base n of m. Maybe I should start out with that one. So if I have, for instance, if I have log base 4 of 7, I could find that on my calculator by doing log of 7 over log of 4. And I can use any base. So in this case, I'm changing it to base 10, right? Because there's no like little base written. I could also change it to base e, natural log of 7 over natural log of 4. I could change it to anything I want. I could do log base pi of 7 over log base pi of 4. It doesn't matter. Okay, I can change it to any base. So this could be log base c of m over log base c of n, or natural log of m over natural log of n. Right, it doesn't matter what we change it to. So I always tell people that the subscript goes to the bottom, and I don't want to say bigger number because sometimes it's not a larger number, right? The number that's not a subscript goes to the top. So if I have log base 8 of 5, I could write this as log of 5 over log of 8. So the 5 goes up, the 8 goes down. And I can use log, or I can use natural log. I can use anything that I want. And it works out to be the same. So you can check on your calculator. So if I do just regular log on my calculator, log of 5, and then divide by log of 8, I get 0.77, what did I want? 5 decimals. So 77398. And I could do that the same. Oops, I don't know why I opened PowerPoint. I could do that with natural log of 5. So natural log of 5 divided by natural log of 8. I could do natural log instead. I get the same thing, 0.77398. Does that make sense? Okay. Most of you guys probably have newer calculators, and you guys have something called log base. Do you guys know that? So if you hit math and you go all the way down, you get to log base. But some of those older calculators don't have that. Especially like most schools make you use scientific calculators. Like if you went to school at Carmel, they would make you use a scientific calculator for this class. You wouldn't be able to use a graphing calculator. So kind of frustrating, huh? Aren't you lucky that you get to use a graphing calculator? Man, so lucky. All right, so log of 21 over log of 11. Or natural log, doesn't matter. Log of 21 divided by log of 11. So we end up getting 1.26966. 1.26966. Good? All right, and this last thing says, use a graphing calculator to graph log base 6 of x minus 1 also use the calculator to find the solution to something like log base 6 of x minus 1 equals x squared minus 10x plus 23. So if you have a logarithmic equation, x minus 1, it shifts to the right, you're going to have some kind of curve like this that has a vertical asymptote there. We're saying, where does it cross a parabola? Okay, and you need to think about your windows on this. So let's go ahead and start it. So if you guys have the log base button, which I don't think my calculator on here does, like I go all the way down and there's no log base. So I would have to put this in for y1, like log of x minus 1 divided by log of 6. I would put that into my calculator like that. Does that make sense? Okay, if you don't have, like if you have the log base button, I would just use that. So I'm going to put that in for my y1. And then for y2, I'm going to put the x squared equation. So tell me what we know about this parabola. Does it go up or down? Do you think I'm going to see it on my calculator? Look, I see the log equation. And notice how the log equation doesn't go all the way down. Once it gets close to that vertical asymptote, it doesn't do it. Ah, I actually do see it. I'm surprised. I didn't think I was going to. Okay, you kind of have to know your window sometimes. Like this one has a y-intercept of 23. So I wouldn't be surprised if it was up much higher. But I guess it's okay. It's there. How many times is it crossing? It crosses the logarithmic equation twice, right? So I want to find both of those intersection points. Actually, it's above the axis. Let me do that again. So I want to find both intersection points. So do you guys remember how to do this? So try it along with me. KJ, do you want to use one of my calculators? Grab one of these. So I'm going to do second, trace, intersect. And I'm going to trace along there. Yeah, just grab one of those. It's fine. And graph each one for y1 and y2. So I got like 3.421. Did you guys get that for the first one? Do you have it, Gabby? Did you get it? Am I too speedy putting it in? And then second, trace, intersect. So go over to the second point and get right on top of it, and then just hit enter, enter, enter. And it will say intersection 6.724. It's a line. Maybe you forgot your squared. Oh, you have to put it in the second. Yeah, so y2 is x to the 2 minus 10x plus 23. Sometimes our calculator messes up and it doesn't graph that second one. So, all right, KJ, you got it? So you're going to hit y equals, and you're going to put this in for the first one. And you're going to hit y equals and put this in for the second one. And then you'll do second, trace, intersect. And you'll find both of those intersection points. So that solved the equation, right? And that's a hard one. Do we know how to solve an equation that looks like that? Like a log equals x squared? No. Like, how do you solve that? There are ways with like advanced calculus. You can write in you can make log look like a polynomial. Isn't that crazy? All right, we're not going to do that. But it's kind of weird. All right. So I think that was the end of that section, right?